for the session. Okay, so I think we have done some example related with Coulomb's law. Okay, there we have found uh, the field arising from a point charge using Coulomb's law, and field of a line charge. And I think we have done some question related with the volume charge also. Okay, find the electric field intensity using Coulomb's law. Coulomb's law. For these cases, we have done some example. Uh, Now I think we can move to chapter 3. Okay, so it is based on the Gaussian law. Okay, so if I tell you very briefly, this Gaussian law is related with the magnetic flux. Okay, Gaussian law is related with magnetic flux. Gaussian law. This is related with uh, electrical flux. Okay, not magnetic flux, electric flux. Okay, so so we know that electric flux is equal to the charge, total charge. I think this is not a Gauss law. This is Faraday's law or something. Faraday's experiment uh, thing something. Okay. So this is given by Faraday, as I know. Okay. So we know this. Okay. The electric flux. This is electric flux. Electric flux is equal to the total charges. Total charges. Okay. I think this is the basics for the Gaussian law. Okay. So this charge is measured using coulombs. Okay. Coulombs. See. Okay. So electric flux also can be measured using coulombs. Okay. And there is another parameter that is D. Okay. So D is flux density. This is electric flux density. Electric, okay. This is electric flux density, not magnetic. Electric flux density. And that is the flux through a unit area. Flux divided by area, that is electric flux density, okay. So here the unit is flux unit is coulomb, area unit is per meter, okay. So this is C is capital, okay. So this is the unit for flux density, and also we know the relationship. There is a relationship between this flux density and the field. Okay, so that is E is equal to epsilon D. Okay, so this is field intensity. Okay, field intensity. We can measure this field intensity using Coulomb's law. Okay, so these relationships are there. Okay, so Gaussian law states that actually Gaussian law state that the flux. Actually, this is the Gaussian law. Okay, this is the Gaussian law. This definition is related with the Gaussian law. Okay, this Wait a minute. Give me a moment. Okay. I don't know. Some music is playing in my phone. I don't know where it happened. Okay, anyway, we will continue. Okay. Uh, so I think Gaussian law is related with this definition. Okay. So so is the flux density. Okay. So if the flux density is multiplied by area. Okay. So flux density is multiplied by area. Again, we can calculate the flux. Okay. So this is the basis for Gaussian law. Gaussian law states that the, the flux density is equal to the surrounding uh, surrounding flux density of a through a surface. Okay. So to calculate the total flux density, we should do the surface integral. Okay. And this integration should be with the surface. Okay. Within the surface. Okay. So this is the Gaussian law. Okay. So there is another format for Gaussian law that is using the vector divergence operator. Okay. This is the gradient. Okay. This is called gradient. Gradient dot. If we get a dot product of a vector, E is the E field. Okay. This R referred the direction. Okay. So this ER is actually like this. Okay. This is the R direction. Okay. So this E is the E field is a function of R. Okay. So this R is so here the spherical coordinate is used. Okay. So this is equal to rho R. Okay. This is the uh, flux density. Sorry, volume. Sorry, charge density divided by epsilon. Okay. So this is the vector form of the Gaussian law, and this is the integral form of the Gaussian law. Okay. So I think, and there is another important relationship. Okay. Actually, we have already learned that. Okay. In related to Coulomb's law. Uh, that is actually so so this is no. Okay. So the 5. Okay. So we know that 5 is equal to Q. Okay. So Q can be calculated if there is a volume charge. Okay. The Q can be calculated using the volume integral OVdV. Okay. Using the volume integral. Okay. If it is a volume charge. And if it is a line charge, we can calculate this using line integral OL dl. Okay. And if it's a surface charge density, so this is a volume charge density. This is a line charge density. And if the uh, surface charge density, we can have the surface integral. Yes. Okay. So Q can be calculated using these three type of integrals. So that is depend on the charge density. If the volume charge density is there, you have to do the volume integral. If the line charge is there, you have to do the line integral. If the surface in charges are there, you have to do the surface integral. And again, this is equal to the Q is equal to 5. Okay. Then 5 is equal to this one again, Gaussian law. Okay. So that is the surface integral of ds with respect to ds. Okay. So this relationship is also there. I think these are the most important relationship. We need to be careful. Okay. So anyway, we will see how we can apply this Gaussian law to solve some questions. Okay. So I hope these are examples. Those are given. Maybe you can do this by yourself. Okay. For example, if I take so these are very easy, I think, not much difficult. You can do them by yourself. Okay. So here you have to do some integration and only the integration. Okay. So here you have to identify the uh, integration limits and do the integration. Okay. So I think the answer is there also. Then you can try to do this and you can check this with the answers. Okay. So if anyone couldn't do these examples, please contact me. Okay, or send me a WhatsApp message or something. Then I can help you to solve this. Okay. And oh yeah, I think this one also maybe you can try. Okay. So if I tell you how to do this, okay. So try to do this. I will give you a hint. Okay. So here actually the electric flux density is given. Okay. So this is the electric flux density. So this is given in. Can anyone understand what is the coordinate system they used here? So that is very important. Okay. You have to understand the coordinate system. Okay. Because here you have to do the again surface and volume, most probably surface integration. Okay. Most probably you have to do the surface integration. Okay. So, so I think I have given this equation previously. Okay. So if you are doing the surface integration, you need to do the surface, the integration within uh, two variables. Okay. Okay. For example, if you are doing the surface integration, okay. So actually, I always keep remember this one. I can't keep remember. I just refer this one. Okay. So if you need to do the surface integration in Cartesian coordinate or rectangular coordinate, so that can be, so you know that it is like this, x, y, x, z. Okay. So surface may be xy surface, or surface may be zy surface. On other surface is there is zx surface plane. Okay. So these are the surfaces. Okay. So if you need to do any surfaces in this plane, what you have to do, you have to check the relevant plane. If you are doing, if you want to do the surface integral in this plane, you have to integrate it with the function. You have to integrate with dx dy. Okay. If you want to find the zy plane, then you have to do the surface integral. That function should be given. The surface integral should be done in z and y variable with respect to z and y variable. So if it is zx, so this will be function should be integrated using dx z and dx. Okay, so using the Cartesian coordinate, you can easily calculate the surface integration. Okay, but if we have given what is the spherical coordinate. Okay, if we are given spherical coordinate, so spherical coordinate is mainly depend on a sphere. Okay, so this coordinate is r. Okay, and this coordinate is 5 and this coordinate is theta. Okay, so in spherical coordinate we have r, theta, 5. Okay, so we have to do the integration with this one. Okay, so if you want to do the surface integration, here the surface is the surface of this sphere. No? Okay, so your integration should be within theta and 5. Okay, so if you want to evaluate the surface integration using spherical coordinate, always you have to do the integration with theta and 5 variable, with respect to theta and 5 variable. Okay, so theta is coming along with r. Okay, so you have to do the integration. The function should be there. So this function may be a this may be a function of r, theta, and 5, or maybe a constant. Okay, and you have to do the integration r d theta. You have to select this one, r d theta, then r sin theta d phi, r sin theta d phi. Okay, so this is the surface integral using spherical coordinate. And if it is cylindrical, okay, so it is a cylinder. We have to consider cylinder. Okay, so cylinder can be modeled using this value, that is the radius. It is normally referred in rho. Okay, and uh, the 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 this angle 5. Okay, for 5, and the z-axis value z for 5 z. Okay, so these are the coordinates related to uh, spherical coordinates. Okay, so if you want to find the surface integration, so that is the surface of this cylinder. Okay, that is the surface of this cylinder. Then you have to do the integration with respect to 5 and z only. Not rho is not there, because if you consider the rho, it will be a volume. Okay, so you have to do this integration with respect to 5 and z. Okay, so 5 is there with rho. Okay, so the function should be given. So this may be a function of rho theta rho 5 z. Okay, and your integration should be with respect to 5, that is d5. So it is come with rho d5, and then it is respect to dz. Okay, so rho d5 dz. Okay, so this is the surface integration related with cylindrical coordinate. Okay, so you better remember these three. Okay, okay, so you better remember these three, and also the volume integration also. Okay, okay, now I think I hope we have to use only this surface integration. Okay, so we will see. So so if I take this one, okay, so so the flux density is given. Okay, okay, now tell me, what is the coordinate system here they use? So that is very important. To identify the coordinate system is very important. Okay, so what is the coordinate system here? Quickly tell me. Okay, we don't have much time, so please tell me someone, what is the coordinate system here used? What is the coordinate system? You can hear me, no? Tell me, what is the coordinate system? Quickly tell me, what is the coordinate system here? Are you there? Please tell me the coordinate system that is used in this question. What is the coordinate system? මෙන්න මේ ගාන ආදන්න දීලා තියෙන coordinate system එක මොකක්ද? Okay, one answer I got, and thank you for the answer. Okay. Okay. Actually, you it is better to answer the question, okay, because these are very mathematical things. Okay. If I just tell these things, you maybe you can't understand. Okay. You have to do some work there. Okay. If you only work on these things, you can understand this. Okay. You can't understand these things by just by listening to me. Okay. By listening to me, you can't understand this stuff. Okay. Because these are very mathematical things. No. Okay. So actually, this is not Cartesian coordinate. Okay. Because you can see that here the r theta phi are there. So r theta phi is related with what coordinate system? Cartesian coordinate system XYZ, no? Cartesian coordinate system XYZ related with the Cartesian coordinate system. Is r theta phi related with what? What coordinate system? Cartesian coordinate is related with XYZ. So here we have r theta phi. So what is that coordinate system? You know it. I think it is called polar also. I am not sure. Okay. Polar coordinate කියලා තෝකට කියනවද කොහෙද? මට ඒක ෂුවර් නෑ. හැබැයි ඕක spherical coordinate. හරි. Spherical coordinate. මම කලින් කිව්වේ spherical coordinate එක. අපිට polar coordinate කියලා කියනවද මට හරියට මතක නෑ. හරි. දැන් මේ complex number වල එහෙමනම් කියනවා polar මේක කියලා. හරි. ඔය R එක ලියනකොට complex number එක polar form එක කියලා polar form එක කියලා. මම මේක හරියටම දන්නේ නෑ මේ හරි. කොහොම හරි spherical coordinate කියලා මතක තියාගන්න මේ නම හරි. හරි. polar කියන එකත් හරියට දන්නේ නෑ. හරි. මට ඒක ෂුවර් නෑ. So it is related with the spherical coordinate. Okay. So if you are doing the spherical coordinate surface integral, you have to use this one. Okay. So don't forget this. Okay. If you forget this, so you will make mistake. Okay. In the exam. Okay. So now the given electric flux density is there. Okay. So it is flux density. So what is this? This we know this. Okay. Now we should familiar with this. What is this AR means? So if you consider the spherical coordinate, okay, if you consider the spherical coordinate, X, Z, okay. So you have to consider the sphere, okay, this sphere. And this is R, okay, and the R direction is this one. So that is the R direction is shown using the unit vector, okay, unit vector in R direction, okay. So that is the area, okay. So this unit vector emphasizes the direction of this D, direction of this flux density D. So it is along the radius, R direction, this direction, okay. So that is also very important. You need to understand the direction of the flux density, okay, in free space. Find the E point at electric field එක හොයන්න කියන මෙන්න මේ point එක. Okay, so we need to find the electric field in this point. Okay, so the point is R is equal to 2. Okay, so let's say that my point is here. Okay, so R is equal to 2. Okay, R is equal to 2. And theta. Theta is the value. This R is this R angle with Z axis. Okay, so this is the theta. So theta is 25. Theta is 25, and 5 is the angle of this image. Okay, of this image on XY plane with respect to X axis. So this is the 5. Okay. So 5 is theta is 25, 5 is 90. Okay. 5 is 90 means actually where that if the 5 is 90, what is that? So it is in which plane? This point is in which plane? If 5 is 90, this point is in which plane? It is ZY plane. Okay, if this 5 is 90, okay, 5 is 90 means this one. So Z in ZY plane. So our point is in ZY plane. Okay, okay. So that is very important. Okay, now so we have to find the E field. Okay, so how E field? So we know that E is equal to epsilon D. Okay, E is equal to epsilon D. Okay, so this E also in AR direction. This E also in AR direction. Okay, I think so. You need to do, no need to do any integration. Okay, so you can just find this E using this one. Okay, so E in also in R direction. Okay, so you can calculate E using epsilon D. Okay, so D is nothing but 0.3 R square AR. Okay, this is D. Okay, so here this 25 and 90, these coordinates are not relevant because this D is a function of R square only. Okay, so you can apply this R is equal to 2 here. Okay, then you can find the E field, epsilon naught 0.4 2 square. Okay, so this should be the answer. Okay, so calculate this. Okay, so it should be this one. Okay, so you can see that it is in AR direction. Okay, because this AR is there, so this AR is also there. Okay, so it is in AR direction. Okay, so I hope this will be okay. Okay, so for first part, you no need to do any integration. Okay, Then the second part is find the total charge within the sphere. Sphere R is equal to 3. Then we have to do an integration. Okay. So now they ask us to find the total charge within the sphere. Okay, so we need to find the total charge within the sphere. So that sphere is R is equal to 3. R is equal to 3. Okay, so that sphere is R is equal to 3. Okay. So, okay. So we know that the total flux density. Okay, so here directly we have to use the Gaussian law. Okay, so directly we can use the Gaussian law here. Okay, actually, most probably most questions you have to use the Gaussian relation, Gaussian law directly. Okay, okay. So you can apply the Gaussian law. Okay, so what is Gaussian law? The total flux. Okay, total electric flux leaving this space. Okay, the sphere space. Okay, sphere surface. Sorry, sphere surface is equal to. We need to do the surface integral d ds. Okay, so we have to evaluate the surface integration. Okay, so it is very easy. Okay, it is very easy. So previously I told you that. Okay, previously I told you that if it is a sphere, okay, and if it is a surface, we have to do this integration. Okay, so that is nothing. That is nothing actually. So we have to evaluate this 5 is equal to, there are two integration. We have to do the integration with respect to theta and with respect to 5. Okay. So our function is there. Function is this one. 0.3 R square AR. 0.3 R square. And this AR is there. Okay. Okay. So this is a unit vector. Okay. This is a unit vector. It emphasizes the direction. Okay. And we need to do the integration with respect to d phi and d theta. Okay. But don't forget d phi and d theta. D phi is come with r sine theta. D theta coming with r. Okay. So there are r d theta, r sine phi, d phi. Okay. So r into r sine theta, that will be r square sine theta. Okay. So here we have r square sine theta. Okay. This term is there. Okay. So I think I very briefly explain how this, why this term is coming. So that is, we have to use that curvy linear coordinate systems based on the curvilinear coordinate system theory. We get this term. Okay, so don't worry about this term, just keep this, remember. Okay, so this should be r sine theta d theta d phi. So you have to evaluate this integration. Okay, so when you are doing the integration, okay, so you can see that this integration with respect to d theta and d phi. So d theta and d phi. Okay, so the so the so if it is a vector, so you are considering only two vectors, okay, d theta and d phi. So the directions are already included with this one, okay, but r direction is not there. So we have to put the AR also here. The R direction also we have to put. Okay. So then this AR into this AR. So there is a dot product. Okay. This is the vector. This is the vector. So we have to get a dot product. Okay. If we get a dot product, what is the answer? Can you remember the dot product? පටල ගන්න එපා මේවා. මෙයා මේ පොඩි මේවා තියෙන්නේ ඒ වගේම තමයි එන්නේ හරි. dot product එක මටත් හරියට මතක නැහැ මම කියන්නම්. නැති this is the dot product. Okay. So if you are given two vectors a b, a dot a b dot product, this is the definition. The magnitude of a, magnitude of b cos theta. Okay. So now we have ar dot ar. Okay. So we have to get ar magnitude cos the theta between ar and ar. Okay. So ar and ar theta will be 0. Okay. And what is the magnitude of ar? This is a unit vector. Unit vector means the magnitude is 1. And here also 1. So 1 into 1 cos theta is also 1. So if two unit vectors are added, the product, we have 1. Okay. We have 1. Okay. So you have to consider that one also here. Okay. Don't get confused. Okay. So ar dot ar, so it will be 1. Okay. So this vector part will be cancelled. Then you will have a scale actually here. So this will be a scalar. Okay. This will be a scalar. Okay. Actually phi is a scalar. Okay. Phi is a scalar. Okay. Okay. Now you can evaluate this phi. Okay. So if I write it here, phi. So we know that phi, the theta, the phi angle means this the x-axis angle. So that is we considered from 0 to 2 phi. Okay. So if we consider it from 0 to 2 phi, the theta angle we are not consider 0 to 2 phi. We consider only 0 to phi. Okay. So the theta will be 0 to phi. This is phi. This is theta. Okay. And 0.3 r square. Again, r square is there. So r fourth is there. Sine theta, d theta, d phi. Okay. So this is phi limits. This is theta limits. So first you should do the integration with respect to theta. Then you should do the integration with respect to d phi. Okay. Then check. Okay, do that integration. Then I think you will get this one. Okay. Then so you are doing the integration with respect to d theta and d phi. So once you do the integration and apply the limit, you will get the final answer within r. Okay. So you have to find the total charge within the sphere r is equal to 3. Okay. So then you have to apply so you have to substitute 3 instead of r. Okay. Okay. Then you will get this answer. Okay. So try it. Okay. So try it. So what you need to do is I will tell it again. To find the phi. Okay. To find the phi, you need to do the surface integration using the spherical coordinate. Okay. So you have to do the integration with respect to phi and with respect to theta. Okay. The phi is from 0 to 2 phi limit. Then theta you have to consider from 0 to 5, not 0 to 2 phi. Okay. So your function is there. The ds function that is actually 0.3 r square. 0.3 r square. Okay. So you have here the direction is also given using the unit vector. This is the unit vector ar. Okay. So when you are doing the integration with respect to d phi, d theta and d phi, okay. So d phi come in with r sine theta, d theta come in with r. Okay. So r into r sine theta, you will have r square sine theta. Okay. And this is a vector. Okay. So theta phi direction are also already there. So you have to put the other direction, r direction. Okay. Then this ar, there is a dot product. So it is 1. So this will be 1. If you get the dot product of these two unit vector, it will be 1. Okay. So finally, you have to evaluate this. Okay. Finally, you have to evaluate this integration. R square sine theta d theta d phi. Okay. So first you can do the integration with respect to theta. Okay. So first you can do the integration with respect to the theta, this integration. Then you can do the integration with respect to d phi. Okay. So you will get the answer from R. Then you have to apply R is equal to 3. Then you can find the total charge, total flux within the sphere. Okay. So that is the procedure. Okay. That is the procedure. Please try to understand that procedure and do this integration by yourself. Okay? So I hope you can do this integration. Okay. So it is not much difficult. Okay. So sine theta d theta, that is minus cos theta. So apply 0 and 5, you will get the answer. I think you will get 1 or 2, maybe 2. You will get 2 or 1, maybe. Okay. For example, if I integrate sine theta with respect to d theta, so that is minus cos theta, no? Minus cos theta. So the limit is from 0 to 5. 0 to 5. So, so if I apply minus cos 5, cos 5 minus cos 0. Okay. So cos 5 is minus 1, no? Like this, no? This is 5. This is 0. Okay. So cos 5 is minus 1. Cos 0 is minus again 1. Okay. So here minus is there, minus 1, minus 2. So it will be 2. Okay. So if you integrate this, okay, if you integrate this, instead of sine theta, you will get only 2. Okay. Here, with respect to sine theta, you will get thing. Okay. So this is this is uh, it's called, this is constant with respect to theta. Okay. So that part is there. That part is there. Okay. 0.3 R square. So you will get R4. Okay. So once you integrate with sine theta d theta and apply 0 to 5, you will get here 2. Okay. Then you have to integrate 0 to 2, 5. D5. Okay. So 2 into 0 to 2, 5, that is 0.6 R4. Okay. So theta, so 1 is integrate with respect to theta. So you will have theta here. So once you apply the limits, you will have 2, 5 minus 0. Okay. So your answer will be 25.6 R square. So here you have to apply R is equal to 3. Okay. Then you can calculate this 5. Okay. So this value will be equal to this value. Just try to calculate it. Okay. Just try to calculate. Okay. Okay. So I think that kind of things you have to find. Okay. So that is not much difficult. Okay. Okay, that is not much difficult. Sorry, R is equal to 4. Okay. So here you have to apply R is equal to 4. Okay. So I think these are not much difficult. You can calculate very easily. Actually, this phi is equal to theta. Okay. Phi is equal to Q. Okay. So here you are asked to find the total charge. Okay. So that is Q, the same. Okay. Same thing. Okay. So here R is equal to 3. Okay. Here R is equal to 3. And total electric flux leaving the sphere. That is also when here for this one, you have to apply R is equal to 4. Okay. So that is it. Okay. So try to do this. And I think I will do another example.